Welcome to the course on physics of renewable energy systems. I am happy to see that you have decided to take this course on physics of renewable energy systems. This course will be offered by me. I am Professor Amreesh Chandra, currently working as a professor in the Department of Physics at the Indian Institute of Technology, Kharagpur. Along with me, you will find two teaching assistants, Mr. Sudipta Biswas and Ms. Ananya Chaudhary, who would be coordinating this course along with me. The details of Mr. Biswas and Ms. Chaudhary are given in this slide, and you can contact them anytime during the course if there are any queries or you need some clarifications. So, let me give you a brief overview about the course. See, for a country like India, renewable energy systems will be playing a critical role. It will ensure energy safety, security and sustainability. And with the fast growing need for off-grid applications in areas ranging from villages to hills to remote areas, we need to develop systems which can cater to these needs. And India has realized that these technologies will have to be based on renewable systems. And this will be introduced to you in this course, and we will give you a brief overview of the topics which are relevant to India, and then one by one we will be giving you detailed description about each of the technologies which can become useful to our country. We will also show you that the growth of the renewable systems is directly linked with the development of smart and new materials. And therefore, we will also be spending significant amount of time of the course on discussing about the materials which are relevant to energy systems such as the ones based on solar energy, wind energy or water based energy sources. We will try to convince you that it is absolutely essential to understand the fact that the renewable based energy systems suffer from an intrinsic limitation that is called intermittency. We mean that the source may not be continuously available. So, there will be times when the source will be available and then there would be time when it will not be available. For example, sun. It is available during daytime and then it is not available during night. So, solar based systems can operate at their best when the source is available, that is during the daytime. So, when you have the source and you are generating electricity, then it is also important to store that energy so that you can cater to the needs for use during the time when the source is not available. That is why renewable based energy landscape will have energy storage devices as the integral component. And these kind of energy storage devices can be classified under chemical, mechanical, thermal or electrical type energy storage devices. And these would also be explained during the course of this 30-hour lecture course. And you would see that we will spend 2 to 4 hours on giving you the basic introduction, then we will move to solar power, then we will move to wind power, because these two technologies are going to become extremely useful to India. Solar and wind will become extremely useful for India. So, we will start with these two technologies. We already have water based hydroelectric plants and new technologies will come in, and those will be discussed after the discussion on wind based power systems. Subsequently to water power, we will talk about tidal and geothermal power, which are new and upcoming technologies and can become relevant for many places. Before we go to the characterization techniques, we'll be giving you a detailed description about the energy storage technologies that would become useful for our country. And finally, we'll also talk about the various experimental characterization techniques. Those are used to characterize both energy generation units and energy storage systems. These are the books which we would be following during the course, and as we go along, if you will find that I have referred to any other reference book or any other literature which is published, that detail will also be given in a particular lecture. Thank you and enjoy the course.